Hello everyone. Today we are going to learn 4.3 residual and explained variables. No, sorry, variation. Mistake the first time in the beginning. All right. We have a learning objective here. So let me see. We have scope. So scope of the least squares regression line, right? So scope means the range of x values. The scope is range of x values. Okay. Then we have residual, right? Coefficient of determination. Okay. I'm going to explain to you why name is the least squares regression line. All right, because I did not explain to you last section. So I'm gonna explain it to you this section, right? I told you about the previous video, right? Okay. What we are doing this section. So why we have to have a scope? Why we have to have a range of x values? Because here is the example. They say that weight of car in pounds, that is x-axis and y-axis. So fuel efficiency in miles per gallon. So miles per gallon, we said MPG, just using first letters, right? So, so weight of car in pounds, and then fuel efficiency in miles per gallon, MPG, right? So we know the x-axis is explanatory variable, and then y-axis is the responsive variable, right? Okay, then the last time we interpret about the y-intercept, right? What is the y-intercept? When x equal to 0, right? Then how do we make x equal to 0 in the case? Can we make the carb weight 0? No way, right? And then we had the last time total fat in the fast food, like a hamburger, right? How do you make fat is 0? Impossible, right? That's why we have to have the scope. What is the range of the x values? We cannot have way bigger car, right? That's impossible as well, right? Yeah. So we have to have range of x values from certain pounds to certain pounds, right? Make sense? Yeah, that is talking about. Yeah. So we have a limit about the weight of a car. Yes? All right. Now, yeah, the important point is what I talked, right? And then scope. What's the scope? Scope is the range of x values. Yeah. Okay. So range of x values, what is the range? We knew, right? Maximum, the difference between maximum value and minimum value. How do we indicate it mathematically? So range equal to max minus minimum, right? So that is the one. So let me write down range. Max minus minimum. Okay. So that is for the scope of the linear regression model, right? Okay, now let's take a look the picture so that we understand, right? That first scatter plot, right? That's the minimum in x values. This is x-axis, right? So this is x-axis, which is explanatory variable. And this is y-axis, which is response variable, right? Okay, so we have to have a scope of linear regression line, right? Why? Because we cannot have impossible tiny, no, actually this is 0, right? When x equal to 0, we cannot have x equal to 0, right? In that case, yeah? Well, and then we cannot have a too heavy car. There is no way, impossible. Both are impossible, right? Yeah. So impossible. Car weight. In that case, impossible car. Oops. Weight. And in general, we don't know what is outside. We're not sure about that scatter plot, whether linear or not. That's why we cannot have that. Make sense? Because we had linear regression line, right? When this one happened, when the correlation is significant, right? So we don't know it's outside of scope whether they have correlation is significant or not. All right? In general. Make sense? Okay. All right, let's do this example. So this is what we did in the previous section. So we have y hat equal to 5.9 plus 0.71x. Talk about the total fat versus protein, right? Okay. Now, the question is, can the model be used to predict the amount of protein for meals with 0, 40, or 100, right? Okay, so we had earlier, we can predict in the scope of this regression model, right? So we have 0. We don't want that, right? How about 100? Can you see that this is X? This is Y, right? The minimum in the case, which is 8, right? Maximum in the case is 54. So it must be in that range, right? The scope, right? So this is not the one, right? So 100, so we don't want that. So 0, we don't want, 100, we don't want, right? Okay, then let's calculate the 40, all right? All right, so we have y hat equal to 5.9 plus 0.71x. And then when x equal to 40, right? So we have y hat equal to 5.9 plus 0.71, 40. Can you please calculate? Yeah, so you have a 34.3. Okay, very good. Okay, so we can predict, right? So when the total fat is 40 grams, then we will have 34.3 grams of protein, right? Okay, let me write down on average, right? Because we cannot have exact 34.3 grams of protein, right? So it's average. Make sense? Yeah, then book indicated that even though we have a scope of the least squares regression model, right? We can more extend. So they say that we can have 5 to 10% of range of X values. So we had minimum is 8, maximum was 55. So if we calculate 5%, then that's 2.3. And then if we calculate 10%, that's a 4.6, which is around the 5, which is around the 2 in that case, right? 2 and 5, right? So we can make from the minimum, we can more lower 2 to 4 points, or from the maximum 54, 2 to 4 points. Yeah. Okay. So that is the one. 2 to 4 points lower than 2 to 4. All right. Okay. Now let's talk about the residual. Yeah. All right. So we have a residual. What is a residual? So residual is the difference between actual y value and the predict y value. So actual y value we have from the table or given, right? And then predict y value, we have a y hat as a equation, right? So least squares regression line, right? From there, we predict, like earlier, what was the total fat 40 grams? What's the protein? So we predict that y, right? So we had a 30 something earlier, right? So difference between actual y and then predict y. Make sense? Yeah, let me not calculate, highlight residual. Observed y, predict y, right? So which is y minus y hat, right? Okay, now we have some property about the residual. So we have data points above the regression line will have a positive, and then below the line will have a negative. So since we have, let me show you, this part is a positive because above the line, and this is negative because below the line. Then there's some because positive, negative, right? There's some will be 0. Yeah. Okay. Then I told you I'm gonna explain why the name is least squares regression line, right? So here we go. So we have least squares regression line. It's a line that makes sum of the squares of residual as small as possible. Small as possible, that means least squares come from. Okay, then why we square them? Because the sum of residual is always 0, right? We don't want a 0. 0 is meaningless, right? So we want to make a square them. Okay, because we say the difference observed y and predict y, we call this is the error. Yeah. So we don't want to make it too messy. And then we don't want to make their sum equal to 0. Yeah. That's why we make a square them. So we want to minimize the error. That's why we square them. Make it clear to you? Let me write down. And then book indicated that the sum of squared residual is called unexplained variation, right? So here we go. Let me highlight. And then we're gonna talk about the later on after residual. All right, so we have this example. This is like miles per gallon versus weight, right? So we have weight is x-axis, which is explanatory variable, right? And then miles per gallon is y-axis, the response variable, right? Okay, the first one, predict the gas mileage when the car weight is 3,339 pounds. All right, so let's do that. We had the experience, right? So we had y hat equal to 49.4 minus 0.0073x, yeah? Okay, so when x equal to how much? When x equal to 3,339, yeah? Okay, so y hat equal to 49.4 minus 0.0073. Can you calculate? So what do you get? 25 approximately. Okay, yeah. Round, right? So round. Okay, then when the car weight 300 I'm sorry, 3,339 pounds. So we are using that symbol, right? Pounds. We then the how much mileage per gallon they're using? 55 file 25 miles per gallon. Miles per gallon. On average, right? Yeah. Okay, second part, yeah. Second part, we want to find the residual, right? So residual, which is difference between observed y and expected y. Expected y, the predict y. Predict y, yeah? So, okay, so second part, oh, I need another page. Second part, residual. So let me use residual like that, right? So it observed y minus predict y, right? So that is y minus y hat, right? When x equal to 3,339, right? So, ooh. So when x equal to 300, oh, there you go. They highlighted, right? 300. So why I kept saying that? So sorry. 3,339. That's miles per gallon is 19, and then we found 25, right? So there will be 19 minus 25. So there will be 19 minus 25, right? What do you get? Negative 6.0. Yeah. So negative 6, same as. We get the negative means from the line is below, right? Yeah. Okay. Now we need to interpret, right? So they said interpret the residual. What they say, does the Chevy Camaro get better or worse gas mileage than expected based on its weight, right? Okay, what do you think? So the table gives us 19 miles per gallon, right? But then we predict was 25, right? And then we have a residual is negative, right? So that means that is worse than the predict. So we can interpret Chevy Camaro gets 6 miles per gallon less than the average of cars of same weight. Make sense? Okay, let me write down this. All right, so I wrote down here what I said. Okay. Let me double check. There is a little bit weird. Average cars. Yeah, it was weird here, so I changed that. Okay, so can you please try this one? Try. Okay, so we have a terminology unexplained deviation here. So the data points that are not on the regression line are not where they were predicted to be and have what we call unexplained deviation. So let me read this one, right? So unexplained deviation comes from factors. This is a better understanding terminology. So unexplained deviation comes from factors other than weight of car, about the mileage per gallon, right? So fuel is hard to pronounce. Fuel efficiency is also impacted by aerodynamics and engine size, right? Yeah. So we can think about that. Not only weight of car, right? Okay. Also, here's an example. The workers getting paycheck, $20 per hour, right? Then 1 week less work, 1 week more work. So less work, then fewer paycheck, more work, larger paycheck. That is explained variation, right? What is unexplained variation in the case? They have a commission, then number and size of commission. There will be unexplained variation because it depends on commission. The person get the paycheck on top of hourly pay, right? Yeah. Okay, now we have another terminology, coefficient of determination. So that is the ratio of explained variation to total variation, or simply the proportion of explained variation. Okay, so what is this? We had R, which is correlation coefficient in the 4.1, right? So we make R squared. So in that case, they're using just the uppercase of R, but it's the same as R, which is correlation coefficient of a sample, right? So we can make a square them. That is a coefficient of determination. So it's a ratio of explained variation to total variation. Okay, let me highlight. Okay, let's take a look. Coefficient of determination. So we had earlier, right? So it's a proportion of a variation, right? Okay, now it's number, right? Coefficient because number. We have a measure of proportion of variation in y that explained by x. And then, as I told you earlier, we're using R squared. So we can have that from the secant, R squared. There is R squared like that in the secant. Okay. Then how do you make a percent? We can make a percent easily, right? The times 100%. So this is a percent of a variation in the y variable that is explained by x variable, right? Yeah. Okay, let's take a look. When r squared equal to 1, more variation is explained by regression model. So that is this one. Yeah, perfect. So we had one line, which is correlation was the perfect, right? Yeah, same as here, R square equal to 1, right? So 100% of variation is explained by the regression model. Yeah. And then they say the residuals are all zeros because there's no difference between, right? Yeah. Okay. How about, let's take a look at this one. This is a moderate correlation. And then we can find R square in the second. Yeah. And then there's the less explained variation. And then since moderate, we can say the lower percentage of explained variation, right? Okay, how about this one? It's a strong correlation, right? So strong correlation. We can have that R square is close to the 1, right? Strong, close. And this one not close, right? Yeah. Higher percentage of explained variation close to the 100%, right? Okay. All right, so let's do this example. So computing the coefficient of determination. So we have the table, student exam scores, exam 1 score, exam 2 score, and then the correlation coefficient is given, R equal to 0.8, right? It's a strong, right? So there are the strong correlation, the linear correlation exists between two quantitative variables, right? Okay, now how do you find the coefficient of determination? So we make R square, right? So coefficient of determination is R square. That will be 0.81458. We keep that decimal place as much as we can and then round at the end, right? Okay, what do you get? So 0.66, 0.6635. Okay. What this mean? This means let's make 100%. Then 1, 2, so 66.35%, right? So that will be 66.35% is explained by the exam 1 score, right? So let me write down. So this means approximately 66.35% of the variation in the exam 2 scores is explained by exam number 1 score. Means that exam 1 score is good, then the student study hard, so exam 2 score is good too, right? If exam score 1 is not good, then exam 2 score is not good too. Yeah, same person. The students did not study for the second one too. Okay, then they say that 33 point, the other one, 100% minus 66.35%. Then we get 33.65%. So that is unexplained by exam 1 score. Then what kind we cannot explain, like unexplained, yeah, by exam 1 score, right? So there will be probably those students having some kind of a issue, like a test anxiety or some other exam condition like that, we can guess, right? So unexplained by the exam 1 score. It's not, we can see that only the exam 1 score, right? Yeah. Okay, let me write down what I said here. All right, so I wrote down whatever I said. Okay, now let's do this example, right? So it was R was correlation coefficient was given, and then we could find the coefficient of determination, R squared, right? What if we have a data set? Oh, this is data set what we did last time. I have one here. Oh, I just erased. Oh, okay, let's do that. There is a data set. So let me share screen. Okay, just let's read this one. Let me highlight. Okay, so we have a 71.9%, right? So we have, it's explained by the fat content, right? So which is a protein. We had one, right? So interpret this one, 71.9% of variation in protein is explained by the fat content. And then 28.1%, we get 100 minus 71.9%, right? Then unexplained, right? What kind of unexplained factors there? Is the meal made lean source of protein, such as beans or chicken, or meal fried with lots of cheese? Yeah, okay. All right, so any question? Thank you for watching. Bye. I'll see you in the next video. Thank you. Bye.